So here we have practice problem number 6 on page 205. I'll read the problem. A 60-kilogram person was in the car that hit the concrete wall in the example problem. The velocity of the person equals that of the car both before and after the crash. Thank you. And the velocity changes in 0.2 seconds. Sketch the problem. And A, what is the average force exerted on the person? And B, some people think that they can stop themselves rushing forward by putting their hands on the dashboard. Find the mass of the object that has a weight equal to the force you just calculated. Could you lift such a mass? Are you strong enough to stop yourself with your arms? And the answer is no. Okay, but let's see why. One of the things I told you to do is to start with the impulse momentum theorem. So let's start with that. Force times time equals the change in momentum of the object. Okay. Now this right here is the force that's causing this change in momentum. It's really the net force, but we're calling it the average force because that means we don't really care about the how the force ramps up and gets bigger and then gets smaller over time. We're just saying, hey, what's the average of all those forces times the total time will give us the same change in momentum. So it's our way of being able to calculate, get an idea what the force actually is on the person in that car. So what this allows us to do is say, well, let's solve for the force, and that's going to be equal to the change in momentum over the change in time. And this is Newton's second law expressed in terms of momentum. So this is going to be equal to the mass times the change in velocity over the change in time. Well, the mass is 60 kilograms. The change in velocity, well, that's the final velocity minus the initial velocity. And I hope you remember to put that negative in, or it's going to end up being negative. And divided by 0.20 seconds. If you have that much change in velocity in that little time, that's a real jolt on the system, okay? That could hurt. So 60 times, well, that would be negative 26. And then we'll divide that by 0.2. And we get negative, and the answer is the average force acting on the person is negative 7,800 newtons. And that's for part A. Now for part B, well, what is that in mass? If this was the weight of something, how many kilograms would that be? So you can just take the magnitude of that, 7,800 newtons, and divide it by 9.8 newtons per kilogram. And so let's see, divide that by 9.8. And that's going to be 796 kilograms. Now, I'm going to do something and tell you how many pounds that is, because you guys are used to thinking of this in terms of pounds. You didn't have to do this on the homework or on the quiz, but 796 times 2.2, that's 1,751 pounds of force. Now, in a car crash, and this is a pretty realistic, your arms aren't going to do you any good. If you put your arms out in front of you on the dash, can you lift that? No. Could you lift that? No, you can't. You're not, Superman or whatever. Can you stop with your arms? No. Your arms will break. Whoops. Your arms will break. Did I spell that right? Yeah, K, not CK. A lot of other things are going to break too. So the moral of the story is wear your seat belts. because your seat belts not only are strong enough to withstand that kind of force, but also seat belts stretch. And because they stretch so much, they actually increase the amount of time to change your momentum, and therefore decrease the amount of force. Now, have any of you ever been in a head-on collision? Were you wearing seat belts? Anybody in here? Okay, nobody. Well, you have. You wearing seat belts? And did they obviously you survived. That's good. Did you have any bruises from the seat belts?
Well, my hands, not the seat belt.
Huh?
No bruises from the seat belt.
Okay. I've talked to people who they wear a shoulder strap and they'll have bruises along, but just think what that would have done if they hadn't been wearing a seatbelt. Those bruises would have been on their face as it goes through the windshield. So make sure that you do wear your seatbelts out there, because you can't withstand this much. Your body cannot withstand that much force without serious damage being done. Okay, so kind of an important problem. That is all.